Welcome to TALRadio powered by Touch a Life Foundation. As Steve Jobs once said, innovation distinguishes between a leader and a follower. Today, we are honored to have Mr. Ravinder Vannam, a leader in the textile industry. Along with his brother, he had developed a revolutionary conversion kit that transforms traditional shuttle looms into efficient rapier looms, enhancing productivity and reducing energy consumption. Mr. Vannam's groundbreaking work has been recognized with a gold medal from the Department of Science and Technology of the Government of India and Lockheed Martin, USA. Additionally, he and his team contribute to the future of textile education by awarding a gold medal annually to the top performer in the textile department at the Osmania University. Join us as we delve into the story behind this award-winning innovation and explore its potential to reshape the future of textiles across the globe. Sir, warm welcome to our show.
Thank you. Thank you.
I think you have been in this industry for a very long time. And just before we start the interview, I had mentioned that there are videos of you talking about the conversion kit almost a decade ago. So I would like to start by asking, what was the motivation behind this conversion kit, and what was there any background behind it? Is there any story behind it?
Yeah. Thank you very much. For the opportunity given to me. Actually, I'm not in a very long time in textiles. Thing is, I'm a mechanical engineer from Walchand College of Engineering, Sangli, near Kolhapur. Then through campus, I'll tell you about 2 minutes about my background.
Yes.
And I was recruited in Mahindra and Mahindra. So for 15 years, I was in Mahindra and Mahindra. Then later on, for 15 years, I was with Mercedes-Benz, Pune plant. So I was an automobile engineer, basically. The link to the textiles is my father. We are from the weaving community.
Mm-hmm.
So my father, he was working in textile mill here in Hyderabad. There is a mill called a DBR mill, which got closed down now. And then later on, he moved to Solapur. He worked in Lakshmi Vishnu mill. Then he moved to Bombay. So he had worked in Kamla mill, Rajesh mill, and Jam mill. So he had taught us when we were in 11th standard. He had taught us the power loom in Bhiwandi. At my childhood, I used to do the hand loom in our rural village. And power loom, he taught us in Bhiwandi. So that is how I was introduced to the textiles at very early stage of my life. But then later on, I went to move on to automobile industry. Then in 1982, the textile strike broke out in Bombay.
Mm-hmm.
So lakhs of people were, thrown on the road.
Mm-hmm.
And I had seen many families, who had committed suicides, whose children, whose education got stopped. So it was very disturbing phase for the textile industry. So that time I thought, okay, I should do something for this industry on which my fathers and my grandfathers were depending for the livelihood.
Yeah.
And that was one motivation thing. And then later on, there was one study conducted by, can you see this thing?
I can only partially see it, but it is okay.
This is a study done by Spurti Kolipaka. She did her master's in vulnerability analysis of power loom workers. A case study of the workers in Sirsila, Telangana.
Mm-hmm.
So there, she's from Tata Institute of Social Sciences.
Mm-hmm.
So, and one word about her. She is a BTech electronics, and she had worked in Tech Mahindra. Then after working for a couple of years, she resigned and she joined Tata Institute of Social Sciences, and now she is doing PhD in UK
Wow.
on social work.
Mm,
So there she had analyzed what are the shortcomings of
mm,
the workers, why
mm,
the textile workers, the weavers are committing suicide.
mm,
Every alternate day we see the Sirsila weavers are committing suicides. So
mm,
this was one more, thought-provoking thing I said, I should do something for this. Working for a multinational company is one part, but we should do something for this. Then I gave energy audit exam. I'm
mm,
certified energy auditor. So
mm,
I'm certified energy auditor. So while I'm preparing for the energy auditor exam, it got one subject on the textiles,
mm,
which was very eye opener for me also. So there about out of 12 pages for the textiles, so 6 pages they're covered for the spinning.
mm,
Where the how the yarn is made from the cotton, and then they have given only one para for the weaving. That the yarn prepared is converted into fabric either by weaving or by knitting, and immediately they have jumped to processing, which is again energy consuming thing. Actually, in weaving, about 30% is spinning, and 30% is weaving, and about 40% the processing. That is the energy consumption in the cloth preparation. So I said, oh my God, the weaving they had given only one para. So
mm.
this is injustice to the weaving community, on which
Yes.
so many people lives are dependent. Almost about 45 million people are depending on the weaving in India and many across the world. So I should do something for this. Then in while working in Mercedes, I was in a team to indigenize the fabric of
Mm.
the seat cover of the Mercedes car.
Oh.
So that was a time when I was coming across with the latest mills in
Mm,
India.
mm,
So I worked almost about 1.5 hours on that project, but I could not indigenize it
mm,
because the technology available in India is about 20 years back than what it was available in Germany and USA.
mm, mhm,
Then it was an eye opener for me that we should do something. And then I said, okay, government textile department is there, Sasmira, Nitra, there are so many they are there. So why they are not doing something about it? I was
mm,
thinking, and then I said, okay, leave them aside. What I can do as a person. Then I discussed with my cousin brothers, my brother Narendra.
mm,
He had worked in Bombay dyeing,
mm,
so he got domain knowledge of the textiles. And then other my cousin brother, Mr. Jagdish Chilveri, he's my cousin brother. He also has spent all his life in the power loom industry. And then I discussed with my daughter. I'm proud to say my daughter is also part of our team. On
wonderful.
background you can see a photo.
Yes,
Yeah,
I can see her photo.
she is
Um,
my daughter Aparna. She is BE
mm,
mechanical, and so we four of us we discussed. Then we said, okay, can we upgrade? Then we discussed with the power loom owners that why can't you import rapier loom? They said, oh my
mm,
God, we can't afford the 10 lakhs per loom. We cannot afford.
mhm,
So then told them, okay, if we give a kit to convert it to shuttle loom to rapier loom, is
yeah.
it okay?
Mm,
They said, yes, sir, that is what we want.
mm.
And yeah, I'm now a word about shuttle and rapier.
Yeah, so I was about to ask you that for the common knowledge of people who are our
Yeah,
listeners,
yeah,
we would love to know what is the difference between shuttle loom and rapier loom.
yeah, yeah. This is about my gold medal by Government of India.
India.
Yeah,
Wonderful,
and Lockheed Martin. So
wonderful.
Yeah, and Lockheed Martin is a technical partner to the Government of India, Department of Science and Technology, to pick the most socially relevant innovations. Because in our time, there were almost about 1,400 applicants were there.
Mhm.
So out of which they have selected 30, and ours is one of the 30. So this gold medal belongs to the all textile people who are working all across India, and the people like you who are propagating this innovation to the world, encouraging the new generations. Thank you. And now,
Wonderful,
what
sir.
about what about yeah? This is the shuttle.
Mm-hmm.
Um, yeah, this is called shuttle,
Mm-hmm.
which carries the yarn from one end to the other.
Okay, okay, sir.
Yeah, this is made of wood. So somewhere tree is cut to make the shuttle. Number one. Then this is called pearl,
Mm-hmm.
no, on which the yarn is wound. So there is a pearl winding machine on which this is wound. So what happens is this shuttle carries the yarn from one end to the other.
Mm-hmm.
So there are basically three operations in any loom, whether it is hand loom or power loom. So one is called shedding, in which the shed is made, like this,
Mm-hmm.
through which the yarn is passed with the shuttle. In our case, this case, so this is called picking. And once it is yarn is gone one end to the other, then a beating operation happens. That is when the yarn is taken, the cloth is made. Yarn is taken towards the cloth and the cloth is made. And again, this operation repeats. So
Mm-hmm.
in our case, the yarn is taken by the shuttle, which weighs about half kg.
Mm-hmm.
This is very heavy. And what happens is when yarn gets empty in this pond, the machine stops. So the operator has to come. He has to take out the shuttle. He has to chain this pond with the empty one with the new one, and take the yarn, then match the design and color of the yarn, and then
Mm-hmm.
accordingly restart. And
Mm-hmm.
that is where the defect creeps in. Because, for
Okay.
example, if this yarn gets empty here, the
Mm-hmm.
shuttle doesn't stop here. Shuttle will go there.
Mm-hmm.
So from here to here, there won't be any yarn.
Mm-hmm.
So he has to reverse it, take that half yarn out, then put it. But normally, he's working in all first shift, second shift, third shift. So when
Mm-hmm.
he's working in third shift, repetitive job. So sometimes he forgets it to remove it. So that is where the defect comes in the
Mm-hmm.
cloth.
Mm-hmm.
So in our this is how the shuttle works. And in case of rapier, we remove this, and there is a small rapier. This is called rapier.
Mm-hmm.
So this slides. In case of shuttle, it has to fly. So it has
Mm-hmm.
to something has to hit it very hard. But here it slides on the loom. So the kinetic energy required to propel it from one end to the other is very less
Okay.
in case of rapier.
Mm-hmm.
And in rapier, what happens is one. There are two such pieces, one at this end and other at this end. So this brings the yarn from the comb directly,
Mm-hmm.
and at the center, this picks up and it goes back like this.
Mm-hmm.
So it is how the rapier mechanism works.
Okay.
The speed is double almost. You can increase the speed by 2 times.
Okay.
So that is how the rapier works. And because the yarn is taken from the comb directly, it will work 8 hours non-stop.
Oh, wonderful.
Whereas in case of shuttle, every 2 minutes, every 3 or 4 minutes, the machine stops.
Oh, okay.
Yeah,
Okay.
here it was continuously for 8 hours. So
So,
non-stop.
Through this innovation, I think you are addressing a lot of issues. So, be it sustainability, be it energy consumption, and
Yeah.
also, like you said, coming from the background, which is textile based, you have also seen that you have personally seen people suffering because of not
Mm.
having a technological updation of any sort in the textile industry.
Yeah.
And I think this is something which addresses a lot of problems together. Could
Yeah.
you talk a bit about that, sir?
Yeah, something about the textile thing. Almost about 45 million people are depending on the textiles. It is next to agriculture. It is highest employment giving industry in India and world over.
Mm,
And in India, we are exporting. We are about 15% foreign exchange we are getting through textile exports, which comes to almost 2% of GDP. It is that
mm,
important. And yeah, in case of R&D, there is very less R&D work going on. So one example I'll tell you, we got a patent for this thing. So when we were searching for the previous patent, when it was given for a power loom, it was
mm.
about 40 years back.
Okay.
Yeah, means for
40 years back.
yeah,
Okay.
yeah. So that is the R&D input which is happening on the textiles, and it is a repetitive job, so it is a monotonous job for the worker. And one interesting episode I wanted to share, my father, he could not go to school in his
Mm,
school younger days. So he started going to class and learning English when he was working as a worker on the power loom.
okay.
So what he used to do was he used to make slips of spellings. Then he used to, when he was working on the loom, he used to put those slips and try to read it. The A P P L E, apple, like that, one or two. And then immediately one loom stops. He has to put it down and repair it, restart it, then again reading it. So when he told me this story about 50 years back, I said, why this loom stops every 2 minutes? Suppose if it can work for 8 hours, he can read more, he can by heart more spellings. He could have read more this thing. So that was a thought process which happened. So now I got opportunity to do something for the this thing. And about the energy consumption, every unit we
Mm,
are using here in our house or in the factory, that
mm,
for every unit, 3 units have to be generated at the thermal power station,
mm,
because 2 units are lost in the transmission only.
mm,
That is a transmission losses which we cannot avoid, and we are paying for it.
mm,
Ultimately, consumers are paying for it. And there at thermal power station, for every unit generated, we have to burn the fuel,
mm,
coal or oil, or we have to burn it. And each unit, for every unit we are generating, at 1 kg of carbon dioxide, and 6 grams of SO2, and 3 grams of nitric oxide. So much of pollution is made.
mm,
See, nitric oxide is a carcinogenic gas,
mm, mm,
and SO2 is a water polluting gas,
mm.
and CO2 is which is leading into
Carbon
global
dioxide.
warming.
Mm,
It is a
mm,
CO2 leads into global warming, which is resulting into heavy rains and no rains. We know the problems of global warming.
mm,
So when we are saving 1 unit here, we are
mm.
saving so much of pollution.
Yeah.
And regarding water, a thermal power station water consumption is very high.
Mm,
If you see, all thermal power stations are put near the water bodies
mm.
where a lot
Yeah.
of water is available. So almost about 9 cubic meter per hour of water is required per megawatt.
Mm.
And in industries, almost 88% of the water in industries is consumed by the thermal power stations. So there are almost about 22 lakhs of these shuttle looms, old shuttle looms, still working in India.
mm,
The mills have closed, but those looms, they have taken
mm,
it out and they are working. So
mm,
22 lakhs are working all across India. And
mm,
not only in India, we have in Pakistan, Bangladesh, then places like South Africa,
mm,
Tanzania, because we are getting inquiries from these countries that we do
okay.
have power looms. Can you upgrade it to rapier loom?
Mm,
So far, we have concentrated only in India. We haven't
yeah.
gone abroad because doing business outside, especially this social work, it needs a different set of skills and infrastructure. So
Yeah.
we are concentrated only on India. So even if we convert about 20 lakhs of looms, it will save almost about 2000 gigawatt hours of energy.
Mm,
And almost it is equivalent to one planting about 1.6 lakhs of trees.
mm,
Um, because what happens is every tree
mm,
can absorb 37 kgs of CO2. There's
okay.
an environment point of view. So that
Mm,
way we calculate. And we can illuminate almost for every loom, almost about 25 villages we can illuminate.
wow.
Almost every loom saves about 1 megawatt per year, which is equivalent to almost 25 villages. And there are many villages in India, even now, where the electricity is not there.
Mm,
So we can use that, and almost productivity is increased by 30%. Quality of fabric is improved. Then almost a saving of about 50,000 rupees per person can be saved. And for every loom, 3 tons of CO2 is
wow.
saved,
Mm,
and 16 kgs of SO2 and
mm,
8 kgs of NOx. So much
mm.
of saving we can do it. And
It's
one,
it's such an incredible innovation, sir. So the kind of impact it's having, and I'm just wondering at the scale of it. And you, like you said, an innovation in the textile industry is a thing which happens once in a blue moon, like you had mentioned before. And I was just wondering, did you face a lot of technical challenges initially to propagate this idea?
yeah, yeah. Before coming to the challenges, I wanted to continue with the other advantages. The
Yeah.
noise is reduced by 15%. The
Mm,
noise, because it makes a lot of noise. The shuttle
mm.
makes a lot of noise. You cannot stand near the machine.
Ah,
It makes
okay.
about 110 decibel noise. So the
Okay.
noise is reduced by 15%. And it is safe also, because flying shuttle,
Mm,
sometimes if
mm,
setting is not correct, it can fly and it can hit the worker here.
okay.
So he can die on the spot.
It's hazardous.
Yeah. So even that hazardous level is ergonomically it is improved.
Mm,
And even ladies can operate the rapier loom,
mm,
because we have introduced electrics and electronics. We can
mm,
just stop button, it can stop it. So even otherwise, previously only men were operating it. So even this rapier loom, even women can operate. So it is
mm,
empowering the women. And yeah, other that wood is also saved, because for
mm.
somebody is cutting the tree to make this wooden,
Shuttle looms.
so wood is saved, so trees are saved. Yeah, coming to the challenges, yeah, it is a good question. There were a lot of challenges, because especially after I worked in Mercedes and Mahindras, and we had set up Mercedes R&D in Bangalore.
Oh.
So I know how a multinational R&D works. So when we started it as a household innovation, where we don't have any infrastructure, and the person, so we have to design the cam to convert the reciprocatory motion to the
Mm,
rotary motion to the reciprocatory motion. So to do that, I had to take out my college days, machine design books, and the design of the cam, how it is done, how the dwell, all these things I have to design. And then we had gone to the logistic was the biggest challenge, because I was staying in Pune. I was working in Mercedes. I was staying in Pune,
Mm,
and this designing and the manufacturing was done in Bombay. And the trials we had to do in B1D,
mm,
which is again away from Bombay. And there were some manufacturers who were in Belapur. All these things. Logistic was a challenge, and the electric box we got it done through in Surat.
mm,
So shuttling around these places, and then Monday to Friday my duty, and then Saturday, Sunday this, and logistic was a big challenge. And the person who did the manufacturing the cam, he doesn't know the loom. So
oh,
I requested him, please come to the B1D. I will show you
mm,
how it was. He said, no, 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 I don't have time. You just tell me what you want, I will make it. Whether it is work or not, it is your baby. So then we got one cam done. We took the machine. Then the dual was not correct, so it was not working.
oh,
So then again we came back. We told him this is not working. Then he said, "Okay, you give the design. I got nothing to do with it. You give me new design, I'll make it." Then we got other design, and then we got it on cam computer machine. We got it done on CNC machine. Then that worked. So all this
wonderful.
time, it took almost about the trial and error. It took almost about 2.5 years. Then when our kit was ready, then we approached our friend who got a looms. We told him initially when we told him, okay, this is what we are trying to do. He said, no, 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 ऐसा कभी होता नहीं है. तो अगर होता तो पहले कोई करता था. अभी तक किया नहीं बोला तो होता नहीं है. But when I told him, okay, this is kit, you please give your machine for 1 week. We will put it on the machine and try. He said, no, 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 my machine may get damaged. I assured him, we'll give you machine as it is to you. You will take it, we'll take out our rapier kit and again put the shuttle and give it to you if it doesn't
Mm,
work. He
mm,
said, no, 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 I lost my production, my machine may get damaged. And
mm,
then I said, okay, we purchased a old machine,
mm,
and then we tried on it. Then after some trial and errors, it became successful. So
mm,
that is where we got the confidence. Okay, our theory was correct, and that is how we started showing to our friends. So somebody from Solapur who was having jacquard machines.
mm,
He came, he saw it, he said, "Yeah, this is what I want." So immediately he gave money advance to us. They said, "You
mm,
come to Solapur and convert my machine."
mm,
So, and that was a big challenge because our thought process was initially we do a normal loom
mm.
without any design. And then we loom in looms also there are different varieties. One is a plain cloth. I don't have plain cloth now. Yeah, this is plain cloth.
Yeah.
This
Uh,
is a plain cloth.
yeah.
There is no design or colors. Then second to that is a different this cloth where you
Mm,
have colors.
mm,
So different colors. This is called double petty.
mm.
Yeah, and then we have designs like this.
Yeah.
The no, designs will be there, which is made
Yeah.
with the Dobby. And jacquard is a no ultimate machine where each and every yarn can be designed how it goes. Complicated designs can be done. So we got an order for the very high-end machine, jacquard
Mm,
machine.
mm,
So then we struggled for almost 3 to 4 months on that. Then again we designed and then we got the material. We went there and we got it done. And yeah, that is how the path had gone. Every step was a challenging. We and there was no support from
mm,
institutional bodies, so called.
mm,
And that is when one of my friend from Walson College, one Mr. Bipin Jirge,
mm,
he was already having 4 patents on his name.
mm,
So he suggested me when I was, initial stage. He said, "You better apply for a patent."
mm,
So I said, "I'm not interested. I don't want to
mm,
make money out of this. I
Mm,
want to help the community.
mm,
So I want to, that's all. If I do a patent, if I get a patent, then somebody has to take my permission to do their upgradation. I don't want to be a burden on that way. So he said, no, no, no. You, if that weaver needs some loan, and if he says to the bank that it's a patented technology, then he will immediately will get a loan or subsidy, whatever it is.
wonderful.
Yeah, that is how. Then I said, yeah, if it is helping him, then I will do it. So that is how. And my daughter, she did all the patent work, and she did the search, and there were so many formats which need to be filled up. And that time we were in Pune, so we went
Yeah.
to 3, 4 times. We went to Bombay.
Mhm.
In Antop Hill, the patent office is there.
Uh,
So we did on our own. We didn't hire
okay.
any advocate
Mm,
for
mhm,
applying for the patent, because I already spent almost about 20 lakhs rupees in this
mm,
R&D and coming, going, and
mhm.
trials and purchasing the machine. So then we did on our own, but we have learned a lot in the process. How now I
Wonderful.
can give consultancy how to apply for a patent. So
Wonderful. That's
I,
amazing. So, and I'm just thinking how pure and authentic that emotion was for helping people in the textile community.
yeah.
And hats off to you, sir. I have nothing more to say to that.
And one success story in Sirsila, the one family is having 4 looms. So, I mean, this is other corollary to what advantage society can have. So the father was working, operating the looms in day shifts, morning 6 to
Mhm,
evening 6, and
mm,
son, he was aged about 22. He was operating the machines in night shift, 6 to morning 6. So he had to drop out from the college. He took admission to BSc, but he could not continue because
mm,
after working
mhm,
for 12 hours in night, how he
mhm.
can go to college and study?
Yeah.
And then accordingly, he was working just like that. So in textile, what happens is if a worker, if he is, joins as a worker in a power loom, he will retire there only as
Mm,
a power loom worker. There is no
mm,
other growth or this thing. I'd seen so many, my uncles and my many relatives who have joined as a worker and then retired as a worker.
mm,
There's no other growth or no other learning. So out of 4 looms, we had upgraded only one loom from shuttle to rapier. What the one loom was giving equivalent production of 4 looms in one shift only.
mm.
So the son is free. He went back to college. He completed his BSc. He completed his MCA. Now he is working as a software engineer in Hyderabad.
Wonderful.
Yeah.
Thank you for sharing that wonderful story of how it has been able to transform a lot of people's life. And that's just one example among probably thousands of examples you have similar to that.
Yeah.
So I also wanted to ask, so what would be your advice to the new generation of innovators?
Um, yeah. My advice to the new innovators, new generation innovators is look around you. There are so many problems in at the bottom of the pyramid. There are many challenges which are poor people are facing. The so and because problems are specific to India, the solution has to come from India.
Yeah,
Person sitting
correct.
in R&D in Germany or USA cannot visualize this and make a solution.
Mhm,
So
mhm,
the solutions we have to find out in India, and that is how we should work. That is my suggestion to students and to the new innovators and through all entrepreneurs. So this that is how, and I really congratulate you for taking out these social innovations and spreading the aware. And to the students, go beyond the syllabus.
Mm. Mhm.
Because as I told you about my syllabus for the BEE,
Yeah.
because the weaving was not covered
Only
here.
one paragraph on weaving.
Yeah. So go beyond the syllabus, then you will get solutions and you will get the gold medals.
Wonderful,
If you
wonderh.
if you just stick to the syllabus, then okay, you will get marks, 100 out of 100 and placements and those things will happen. So go beyond the syllabus. That is my advice to students, innovators, and entrepreneurs. And the
Wonderful.
entrepreneurs, they have to go extra mile because I learned a lot in this thing process because they're dealing with different departments,
Yeah.
uh, different things which are not covered in any syllabus.
Yes.
They don't teach in any college or any syllabus how how to deal with the different government bodies. Yeah,
Yeah.
here I would like to share the government is giving subsidy for our innovation.
Hmm.
So the textile department is giving 50% subsidy for this upgradation, and different state governments are giving over and above additional subsidy for this upgradation. So government is also encouraging a lot these frugal innovations which are useful to the society. Yeah,
Wonderful, wonderful.
yeah.
Thank you, sir, so much for this interview because it has been such a delight to talk to you, to talk about your innovation. And I'm just marveling at how heartfelt it is to do something for your community and do something so extraordinary that you're not only uplifting the community, but everything around the community, the environment, the we are considering the sustainability factor. And I really hope this generation has more innovators like you. And with that, we come to the end of this
Um,
episode.
Yeah.
Yeah.
Can I
Yes, sir.
add one more
Yes, sir. Yes, sir.
thing?
Please.
Yeah, while working for the textile department here, they said they don't have a gold medal for the textile department topper. So then that time I have studied in People's High School here in Hyderabad. So the
Yeah.
principal, ex-principal of the People's High School, Mrs. Rajamani. So she said she want to donate some money on in the name of her husband, who was a
Yeah.
scientist in NFC,
Mhm.
to some organization. So I have suggested the textile. So she had donated money for the towards the gold medal towards the topper in the textile department to
Oh,
the
wonderful.
Usmania University. And I'm proud to say from last 4 years, the women student, the girl student got this gold medal.
Gold medals.
Yeah.
Wonderful.
So it's not that I only got,
Wonderful.
I have helped others to get the gold medal.
Gold medal as well.
Yeah. And that was one. And my
Superb.
future plans are, I am working on to still reduce energy consumption
Mhm.
and can decentralize the textile weaving. We can take it back to the villages because my grandfather's time it was in villages. Now it had gone to the cities. I want to working in a project where we can take it back to the villages. That was one project I am having, and I am talking to IIT Hyderabad
Mhm.
to introduce magnetoleviate mechanism in the power loom,
Yeah.
with which the energy consumption will be still reduced and the mechanical wear and tear will be reduced.
Mm.
So I'm working on that project. Thank you.
Wonderful, wonderful, wonderful. So thank you once again to be for being a part of this show, and I'm sure that you're going to inspire a lot of individuals today who are watching this video. Thank you so much once again, sir. It has been an absolute pleasure to have you on our show.
Thank you. Thank you.
Okay. And to our listeners, this is your host, Pavithra Krishnakumar, signing off with today's wonderful episode on innovation in the textile industry. So, thank you so much for tuning in.